So now that we've talked a little bit about the basic statistics that we're going to be dealing with as we're dealing with data, the next thing that we're going to really start to cover is plotting or data visualization. Now, it's really important for us as statisticians, as data scientists, to use data visualization to help not only ourselves, but also our clients, whether those clients are other people in our own organizations, like our managers or the people we're reporting to, or the people we're doing analysis for, or actual clients that might be paying our company for some sort of analytical work, that we be able to display quantitative information in a way that is easily consumable for them, right? When you start to look at data, and if we look sort of back at in our last exercise when we were talking about standard deviation, I had brought in this data set looking, and we'll go ahead and look at the entire data set, right? If I look at this data set of just the raw data this is data of 150 different iris flowers, this is really unintelligible. It's really difficult for me to understand very much of this at all. However, if I were to maybe turn this into a data frame using pandas, and then I'll need one more import. I'll need to import matlib.pyplot as plt. If I say data.df dot histogram and plt.show, should work. I haven't tested it out, just coding off the top of my head, but we should get a nice set of histograms here of our data set, right? This tells me a bit more about my data set. This tells me how each of the four columns are distributed, right? I have this first column. It looks like I have sort of a normal-ish distribution. I have some concentrations here, maybe some clusters, right? This second column is really pretty normally distributed. This third column and this fourth column almost seem to be split into two groups, right? And as it turns out, this data set of iris flowers is built for classification. There are 3 different types of flowers, and from this data, you can actually pretty easily tell what type of flower each flower is, based on these 4 measurements from each flower. So when we look at this, right, this is a lot more meaningful than just that series of numbers that we had initially, right? And that's the beauty of data visualization, is that it really makes data interpretable and useful for humans to understand, right? When we just look at a big old spreadsheet full of numbers, we can't really make that good of sense of it. But if we turn those into some plots, some graphs, we can start to see trends and learn about our data and start to make decisions based on that data a lot more effectively. So that's why we're going to use plotting, why we're going to use graphs, why we're going to use data visualization as statisticians, as data scientists in our careers. Now, when we're doing plotting, there are some general guidelines that we're going to want to use, and I'm going to go through these pretty quickly. We're not going to spend much or any time actually learning how to plot in this unit. What we're mostly going to spend time in doing is just making sure that we can understand how to interpret plots, because as we go through a lot of these statistical concepts, as we go through this course, we're going to need to be able to look at plots and understand what's going on. So we just need to make sure that everyone's on the same page and understanding those things. But, when we are doing data visualization, there are some best practices, right? The most important best practice is that you choose the appropriate plot. There are some plots that are better for specific types of data than others, right? So you want to always make sure that you're using the most appropriate type of plot, right? Some plots are going to be more appropriate for time series or proportions, and you want to make sure that you're choosing the right plot that's going to display your information in a way that your audience is going to be able to understand it easily, right? You do want your plots and your graphs to be visually appealing, but the functionality is always more important than the form, right? So if you have a plot that looks great, but it's visually appealing to the eye, but it's difficult for the user to glean information from that plot, then you've gone wrong somewhere, right? And more often than not, the approach of KISS is the best approach, right? Keep it simple, stupid. The more things that you leave off of the plot, the things that don't need to be there should not be there, right? You do want things to be visual appealing, but the function is always more important than the form. It's really important that you don't make plots misleading. There are some ways that you can make plots misleading pretty easily, and it's really important that you work hard to not do that, right? In general, as statisticians, as data scientists, what we're trying to do is we're trying to show accurate evidence. And if we're showing plots that are misleading, then we're doing a bad job at that, right? So we want to make sure that we are not plotting in a way with our data visualizations that are going to mislead our audience. You always want to make sure that your plots are clearly labeled. I think we've all probably been in a math class where we lost a couple of points on a graph because we forgot to label an axis. It seems elementary, but when you have a plot that lacks appropriate titles, it can be really confusing to the user to understand what exactly is going on. They have to start making assumptions, which may or may not be correct. And that's not where we want to end up as someone who's authoring work, right? We don't want our work to be misinterpreted. And as I mentioned before, right, keep it simple, stupid. The KISS, right? We want to create plots with less is more approach, right? We want to avoid chart junk, right? Pictures, grid lines, shadows, unnecessary three-dimensional elements. I think in particular, this is a pet peeve of mine. I think Excel plots in general add a lot of these things that just don't need to be there, right? So in general, you want to avoid chart junk. You want to avoid the use of excess or unnecessary additional colors. You want to avoid excessively bright colors, which might be more difficult for a user to see. And you want to avoid adding anything to your plot which is not absolutely necessary to comprehend the information that it is representing, right? And then the last two things, you want to make plots which are accessible. When I say accessible, that means accessible to a wide audience. Specifically, there is a pretty large proportion of people, specifically men. I think it's about 6% of men have color blindness. So it's important when you're choosing your colors to choose appropriate colors that are considerate of users that might be colorblind. Specifically, you want to avoid using red and green in the same plots. Those are the two colors that tend to look the same to most colorblind people. Those aren't the only combinations that look the same, but if you have a medium green and a medium red and they're right next to each other on a plot, someone who's colorblind is likely not going to be able to tell the difference between those two colors whatsoever. So you want to avoid the use of those together. And lastly, you only want to use plots or graphs when it's necessary. When you have a very small, simple data set, maybe only, if we're talking tablature data like in an Excel spreadsheet, if you've only got 6 or 7 rows, 3 or 4 columns, there's likely not really much of a justification to actually make a visualization from that data, right? You can really likely see all of the trends or all of the things that you need to see in that table without making any charts or plots. So those are some of the best practices for plotting, some general guidelines. Like I said, this unit's not really going to be about making plots. It's going to be more about making sure that everyone has the ability to read them. But I think it's really important to start thinking about making these plots and some of the best practices, because it's definitely an important part of being a data scientist. After you've passed the interview, you're definitely going to work on some data visualization in pre-course. And then once you're in the immersive itself, you're going to be doing data visualization all the way through the cohort. In all of your projects, in your day-to-day work, right? It's really a bread and butter of a statistician or a data scientist. So that's it for this video. In the next video, we're going to jump right into bar plots, talk about how we can interpret those, and we're going to move through each of these charts or plots on the left relatively quickly, and then we'll move on to our next unit, which is going to talk about set theory.